So last topic for our inverse functions, again for us technically it's not that big of a deal, but for those of you who are moving on to calculus this gets pretty huge, and it's actually quite amazing when you think about it. What we're eventually going to do is we're going to go from something that's in terms of sines and cosines and arctangents and arcsecants and all that, and we're actually going to get an algebraic expression like we would have gotten in college algebra. So in essence what we're going to do is we're going to walk from a trigonometric world to a algebraic world, and it's actually quite amazing, and all it involves is knowing our definitions. So for example, remember what arc cosine is, or excuse me, what arc sine is that's an angle. So let me go ahead and say, let's call it theta. We're talking theta is the arc sine of some u. Alright, so this means that the sine of theta is u. Now how in the world does that help me? Well, since we're talking about the arc cosine, and let's just assume everything's nice and positive, we're going to draw a picture in quad number 1. So when I draw a picture in quad number 1 here, right, my angle value, right, will look at something like this in quad 1, and breaking this down into fraction, right, this is basically my opposite over my hypotenuse. So my hypotenuse is 1 and my opposite value is whatever u is. So all we need to do, right, to find my cosine of this angle that we're drawing, because that's what we're taking the cosine of, is I need to know what that side is. I need to know what my adjacent is. And so we know that the adjacent squared plus the opposite squared is equal to the hypotenuse squared. So this adjacent side, let me just write it as adjacent, is u squared and 1 squared. So let me bring this up higher. So we get that the adjacent side squared is equal to 1 minus u squared. Taking a square root, I know there's a plus and minus, but because we're in quad 1, we're going to use the positive. This is the square root of 1 minus u squared. That's our adjacent side. So what's cosine? Well, by definition, cosine is my adjacent over my hypotenuse. So for this, what we get is the square root of 1 minus u squared all over 1. And so basically this is the square root of 1 minus u squared, because the hypotenuse is 1. So we went from something that involves trig functions and trig inverses to something that we probably would have seen, and hopefully you did see, back in college algebra. So quite amazing, and we're doing some review because we're going back and using our right triangle definition for sines and cosines to get the job done. Alright, so there's that. So for the next one, we have the sine of the arctangent of x over 4. We're going to play the same game, right? So let me call it beta. Our beta is the arctangent of x over 4. So we're essentially looking for the sine of beta right here. Alright, and so this tells us that the tangent of beta is x over 4. So again, we're going to assume we're in a nice, simple quad number 1 situation. There's our beta, and it's usually the opposite over the adjacent. Alright, so that's basically telling me that this side is 4, and I know this looks weird, but that side would be x. Alright, if you wanted to get away from the x, y, r's, we're just basically talking about that right triangle right there. So forget about all that. My right triangle, the opposite is x, the adjacent is 4. So in order to find the sine, right, sine is defined to be the opposite over the hypotenuse. So we basically need to find my hypotenuse. Well, what do we know? We know that x squared plus 4 squared is the hypotenuse squared. So we're looking at x squared plus 16 is the hypotenuse squared. Take a square root. The hypotenuse is always positive, so our hypotenuse is the square root of x squared plus 16. So that tells us that our sine of beta is the opposite, x, all over the square root of x squared plus 16. I know we usually rationalize our denominator. We could do that here, but I think the textbook leaves it as that. All right. You could, of course, if I'm wrong, just rationalize it. Right. Multiply both sides, upstairs and downstairs, by that. And I think another way to write our answer is x, square root of x squared plus 16, all over the square root of x squared plus 16. So there's your simplified answer, but I do believe the answer in the back of the book will have that. But again, more amazingly, we went from a situation with sines and arctangents and used our knowledge of right triangles and whatnot, and our new knowledge of arctangent to basically go from sines and arctangents to this nice college algebra expression. I don't know if it's nice, but it is a college algebra expression. So same thing here, right? Remember, this is an angle. How about I call it alpha? Alpha is the arc cosine of x over x plus 1. So we're basically trying to find the tangent of alpha in this situation. Well, this is saying that the cosine of alpha is x over x plus 1. So in terms of right triangles, right, this is the adjacent over the hypotenuse. So if I drew a right triangle in this situation, if this is my alpha, right, the adjacent side is x, the hypotenuse is x plus 1, and what we don't know is the opposite. And that's important because we know that the tangent is the opposite over the adjacent. So we definitely need that opposite side there to finish this problem off. So we know that x squared plus the opposite squared is x plus 1 squared. So this means that my opposite squared is, how about I expand that out? I think that expands out like that. Right? And then we subtract x squared, right? Because we subtract x squared from both sides. So we end up getting that going away. So our opposite squared is 2x plus 1. Taking a square root, we end up with the opposite being the square root of 2x plus 1. And so bringing that into play up here, this is the square root of 2x plus 1 all over the adjacent, which we know to be x. And so that turns into that. Again, we're going from a trigonometric situation to a college algebra situation, which is quite amazing. And we're doing that again by invoking our right triangles, using our right triangle definitions, and just remembering that arcsine, arctangent, and arccosine represent angles. All right, that's the key to getting this started. We're talking about angles, and then once we have the picture representing that angle, that right triangle for that angle, we can find the cosine, the sine, the tangent. We can find anything with regard to it using our old definition of opposites, adjacents, and hypotenuses. Alrighty, that officially wraps up 6.1. Pretty major section, a lot of really theoretical ideas going on. So please make sure you're not just crunching numbers and using your calculator just to do things just to get an answer. Make sure you understand what's happening. That will help you in the future. To help you understand, you got to ask questions. Jump on Canvas and show me your work. Do your explanations. Explain why you're getting this answer, why an answer is what it is. That'll give me an opportunity to correct it and kind of get you on the right track. If you're totally lost, then maybe you better hit me up for an office hour, right? Call me up, email me, and let's hook up and figure out a time where you and I can just physically talk to each other online and try to address some of your questions and issues. All right, other than that, good luck on the quiz, and I'll see you in 6.2.